Welcome to aminacademy.com. In IB Diploma Mathematics, let us discuss about algebraic operation with vectors. So, a scalar is a non-vector quantity. It has a size but no direction. But vector has direction as well as size. In this, if any vector is given, if you multiply with a scalar, a constant, it gives other vector, resultant vector, which have increased size or decreased size regarding the multiplication factor. Look at here. First, we'll do geometric scalar multiplication. First, geometric scalar multiplication, which means a vector is given. Suppose vector A is given. Then, if you multiply this vector A with the constant k, it increases the size or it reduces its size because of the k value. Here, consider this. Suppose this is vector A. This is vector A. Now, consider other vector, but this parallel with this one, and this is vector of k and vector A, where k equal to k is greater than 0, positive number. Same, one more vector, look. Here, this also we can write the vector A in k times. This is vector when k is lesser than 0. Like this, the scalar multiplication of with vector, some vector, it increases or decreases the sizes. Then k may be a whole number or a rational number. Now, same the negative vector. Consider one vector that one more vector here. This is two vectors are given but different directions. So let it be first. This vector is a x vector. This must be negative x vector. Size is same but the direction is opposite. Equal vector means two vectors having same magnitude and same direction. We know that. Next, here, vector in component form. Vectors in component form. What does it mean? Vectors in component form means it have two components in x component and y component. Look at here. Consider one vector. This is a vector given. Now, if you drop a perpendicular and draw a horizontal, this is, here suppose this vector is vector here vector A is given. This is a vertical component of vector A. This is a horizontal component of vector A. Like this we can split. And that here suppose this vector is from vertical side, it is suppose theta degrees. Now, and this vector A can be expressed as, you can see it is x component and y component. This then we can see this way also. That means vector component of x is, let it be x vector then y vector. Means x component is horizontal direction, vertical component is vertical direction. That is x and y directions. Now let us draw some vectors given in this matrix one, like vector 3 and 4. Means how to draw this, means this vector, suppose it is vector A. How to draw this vector? Here x is in 3 distance, y is in 4 distance. Means x is 3 distance, y is 4 distance. Then we can say 4 units. Then we can say, we can draw a vector regarding this. You can say x is 3 and y is 4. Vector A is like that. We can find this angle by using trigonometry also. Here, like vector B, another vector is 0, 5. What does it mean? Here, this vector have no x component, only y component. Let us draw this vector. This is a vertical component only. Now, vector C is, let it be 0, 4. No, 0, 4, 4, 0. Means it have horizontal component 4 unit and vertical component is 0 unit. So let us draw. This is 4 unit. So it is not in the scale, just we are roughly drawing. One more vector, vector D is -2 and -3. What does it mean? Here x component is negative, -2 and y component is -3. So we have to draw this vector like this manner. Look at here. This is vector D. Like this, we can use the directions also. Now, let us do vector addition, algebraic vector addition. Vector additions. Look at here. Let the vector A equal A1, A2, and vector B equal B1, B2. Then vector A plus vector B equal A1 plus B1, A2 plus B2. Now, same vector half vector A plus 3 vector B means first vector is multiplied by half, that is A vector, and second vector is multiplied by 3, then both added here, which is equal A1 by 2, A2 by 2 plus 3B1, 3B2, which is equal A1 by 2 plus 3B1, A2 by 2 plus 3B2. These are addition of these two vectors with multiplying some scalars of first vector and other scalar of second vector, then add them. This is a method for finding algebraic vector addition. And subtraction also the same way, only the sign changes. Subtraction also we do example. Let vector A equal 4, 3 and vector B equal 3, 5. Then what is A minus B? Vector A minus vector B is just subtract from first one to second. That is 1 minus 3 is 1, 3 minus 5 is minus 2. Is that vector A minus vector B? Next one, vectors between two vectors. Vector between 2 points. Vector between look at here. Here we have to calculate vectors between two vectors. That means we have to get 2 points, that each point for one vectors. Then we have to get it the other points. Let it be vector AB. AB equal AO plus OB, or that is B vector B minus vector A. For this, how to show in diagram. Now let the point A and B this space is this is a starting point A and point B. Start point with vectors this way A1, A2, B1, B2. Then vector AB is A1, vector B1, B1, B2 minus A1, A2, which is further echo B1 minus A1, B2 minus A2. This is a vector form. Here, given vector is given vector BA equal 2 minus 3 and BC is minus 3 and 1. Find AC. Find AC. AC is AB minus AC. Therefore, vector AC equal to AB minus BC. AB plus BC. AB plus BC is equal AC, but BA is given. Therefore, from this, AB equal B, vector B is given 2 minus 3, then it is equal minus BA. This is given as BC. Means AB is given as BA is given as 2 and 3. So minus BA is minus 2 plus 3. Change the signs. And BC is as it is minus 3 and 1, which is equal minus 2 minus 3 is minus 5, minus 3 plus 1 is 4. Look at here, AB can be written as minus BA. One more example in different form. Find vector AB when point A is given as 2, 3 and B can be written as 5, 8. For this horizontally given. This also same way. Therefore, vector AB is equal vector B minus vector A, which is equal 5 minus 2 is 3, 8 minus 3 is 5. This is vector AB. And also it is given in vertical form, also I can write this also. Now next one, algebraic length of a vector. Algebraic length of vector. Your algebraic vector have, we know that it's a magnitude and direction. We have to find the magnitude of the vector given, that is algebraic length of the vector. Here, consider a vector this is a vector. You have to find a length of this vector with a given vector. Suppose this is a vector A. Now you have to drop a perpendicular and horizontal from the endpoint and starting point. Here, suppose this is length 3 unit, this is a 4 unit, then vector A is given as not vector, modulus of vector A means it's equal to a squared modulus, which is equal to this simply can get it A, which is equal square root of 3 square plus 4 square. Therefore, A equal to square root of 9 plus 16 equals square root of 25 is 5. Therefore, magnitude of this vector is 5. That is algebraic length of this vector. In general, if vector A is given as A1, A2, then we can say modulus of this vector. That means algebraic length of this vector is absolute value vector, that's equal square root of A1 square plus A2 square. Now, an example, if P equals 1 and 3 and Q equals -2, 4, find length of 2P plus 3Q. First of all, you have to find vector 2P plus 3Q is adding of multiply with 2 into 1 is first multiply with 2, 1 and 3 plus 3, Q is -2 and 4. First of all, I calculate multiply with 2, that is 2, 6. Here -6, 12. Add them. 2 minus 6 is minus 4. And 6 plus 12 is 18. Then this is equal vector 2P plus vector 3Q. Then we need length of this vector is modulus of 2P plus 3Q equals square root of -4 square plus 18 square. So let us calculate. Let's calculate these values. Here 4 square is 16 minus 4 whole square is 16 and 18 square 324 equal and 1 carries 2 4 340 square root of 340 is approximately equal 18.44 units, length units. So which means we got the length of this vector to p vector plus 3q vector. So far we discussed about algebraic operations on vectors, that means scalar multiplication of vectors as well as length of the given vector by using modulus and square roots. We have done. Please subscribe our YouTube channel.